record on this computer. Hey guys, welcome everyone to the first ever Amos product call. My name is Dominic Timel. I'm a founder and contributor at Solvio Foundation. And we are here today to discuss the specification of Amos. So let me just say like one or two sentences about what Amos is. Our goal is to essentially categorize human knowledge as represented by learning resources. The end goal is that anyone will be able to search for anything and they will be able to get a learning path that is parameterized to how much time they want to spend on it, and most importantly, what they already know. We're starting with online resources, but the idea is in the future to expand to physical ones as well, whether that includes, like toys, such as these electrical circuit kits that are very, very useful for learning electrical engineering, whether it's museums, technical museums, art museums, walking tours, history walking tours, or physical courses. That we could expand into that later on as well. And in order to really give the best results to our users, the best learning paths, we have to know information about the resources. And we call those information metadata. The most important metadata that we have in our model is the topic, of course. I mean, that's very, very obvious, what topic the resource is on, its length. But really the most important one is the learning dependencies. So what topics do you need to know in order to be able to consume this resource? What topics does it assume you know, or what topics would it be great to know to get the most out of the resource? And our current plan is to get those information about resources from volunteers' contributions. So we are a nonprofit project, and we are starting a campaign or a project really at the ambitions of something like Wikipedia in order to categorize the web semantically. And we are starting with the contributions only version of the app, which we call the supply side version of the app. And the reason is because our app is, its value derives pretty much only from the set of data. For Wikipedia, the value derives from the amount and quality of its articles. For us, the value derives from the number and quality of the metadata of our resources. We call this version of the app Amos 1.0, or the open beta. Cool, so let's talk about the specification. So I've done a lot of thinking in the last 2 days, and things have changed since last week that I posted to the forum. And actually, I'm very, very happy. I think I finally found a version yesterday, and today I spent thinking about it, and it seems sound, that will allow us to make this app, which is super exciting, because whether something like this is even possible was an open question until now. So let me explain what I have in mind. So the knowledge tree that we will be building, it will not necessarily be on the front end. It's a back-end knowledge tree. So the kind of an abstract knowledge tree. So it will be a tree. The nodes in the tree will be called topics, and the leaves of the tree are, by definition, non-divisible. Now, what constitutes a leaf of the tree? So what constitutes a leaf of the tree is essentially how long it takes to learn that topic. So we define a leaf as an average person learning it today, April 30th, 2019, can learn it in 15 to 30 minutes. So usually, for example, for a mathematical theorem, that would very likely be a statement of the theorem and maybe one example. Or it might be a statement of the theorem and a proof. For something non-mathematical, let's say in economics, it might be a statement of some concept, say comparative advantage, and again, one example. So if you accomplish this, you have learned that leaf at level 1. Level 2 would require an extra hour of going in depth. So that might be like, now you see the proof, now you see 3 or 4 more examples. And level 3 would require an additional 5 hours. Now this can very easily be extended mathematically. You can have plus 20 hours, plus 100 hours, plus 500 hours, plus 2,000 hours, plus 10,000 hours, but that's not what we're going to do. Topics should not go further than level 3. If they do, then it's an indication that they can be divided and hence are not non-divisible. So what I've tried to describe here is that only leaves have a concept of depth, or I should say inherent depth of understanding. Cool, let's discuss some more things. So I'm going to skip these 2 points. I'm going to get back to them. How would credentials work? So credentials now in this model are very, very easy. You can only get credentials for leaves. I think this is very, very nice because it's a very, very granular credentialing mechanism, and hence it is much more, yeah, I mean, this is the goal of everything we're working for. What about dependencies? So it is recommended that you list dependencies as a list of leaves, the non-divisible items, but it's also possible to list dependencies as a non-leaf node. Now, before I say that, maybe I should say one more thing, which is, I forgot to write that, depth of non-leaf nodes are calculated recursively using the operator plus. So, for example, if you understand, some theorem at level 2 and another theorem at level 3, and some more definitions in mathematics, like what is the least common multiple and the greatest common divisor, you understand them at level 2. Then you understand, let's say, a node that covers these topics at a level of 9. So to get the depths of non-leaf nodes, you just add up all of the depths of the leaf nodes, and then and then this recursively goes all the way to the top of the tree. So credentials at the moment only for leaves. Dependencies, yes, you may set non-leaf nodes. And what that's going to mean is essentially, what follows from what I said is it's going to be an OR operator on the depths of the actual leaves. So if you say there's a dependency of at least level 10 in number theory, it means you can get that 10 from any of the theorems or concepts in number theory. So as I said, it is not that recommended. It's better to have a more granular approach where we list the leaves, but it's also possible to do this higher level submission, and in that case, the thing is in a or relationship. What about self-attestation? Self-attestation, also, you may do it for higher level topics or non-leaf nodes, but that will only serve when somebody lists that as a dependency. So if you say that you, I mean, there's, maybe this is not the right approach when I think about it, because we want it to be very easy to self-attest to stuff. And if you self-attest to number theory at level 10, then it's very likely you know some of the earlier topics, like some of the earlier topics. I guess there's two options. Either go the route that if you self-attest to level 10 number theory, then that only applies when somebody has entered number theory as a dependency, because essentially we don't know what in number theory you know. But I guess this could be handled on the UX side, where if you enter number theory, it might ask you, there might be, a little like, not a pop-up, but like it might sort of enter a new component, and that would ask you, hey, it's very likely you know prime numbers and GCD and LCM and the Fermat's-Little theorem, and you'll be able to click all of those and make that very nice and beautiful. So I think so. That's one approach, like handle it on the UX side, and then the other approach would be sort of handle it on the backend side, where we would say, okay, if he knows number theory, and then we would have to find some algorithm. This is like, doesn't seem very trivial to me when I think about it, but maybe we could find an algorithm that scans number theory and finds like the topics that he is very, very likely to understand. So then when he's searching for stuff, we assume that he knows that. So this is something that that is still like has to be fleshed out. And finally, we have search. For search, can you search for number theory? Yes, you can. And what would that mean? Well, then we have to, for this one, we definitely have to find an algorithm. And again, it won't be trivial, but we're not here to do trivial stuff. And that algorithm will find the sort of clusters or the largest, largest topics. And it will very likely first try to teach the student those. And then if there's time left, it will go into some topics that are like more outliers, that don't have so many dependencies. But the idea is it will scan through the number theory subtree, and it will teach him everything, of course, according to the learning dependencies. So yeah, I think that's this, everything here seems quite reasonable and doable to me, as in like this is the best idea of how it could work that I've managed to get. And let me just say two more things, the ones that I said I'll get back to. So I also went to khanacademy.org, and I was like looking at, okay, so maybe we should start something that that we know very, very well. We all know high school algebra, high school math or middle school math and elementary math very, very well. And so I got this idea, how would that work? And my proposal is that early stage topics will be topics of their actual academic field. So, for example, middle school algebra will be some kind of, entrance level node in actual algebra, mathematical algebra, which concerns itself with structure, with fields, with rings, with groups, all those beautiful mathematical structures. Of course, there's other examples when you're learning about percentages or ratios or cumulative interest in mathematics, let's say in grade 6 or grade 7, maybe that would be an entrance node in financial mathematics. If you're learning about geometry, obviously, same thing could be applied there. So that raises the question, so then how do we, like, if somebody just wants to learn 3rd grade mathematics, how do we do that? So I think also in the future, we should allow the possibility to add groups of topic, or in other words, aliases for sets of topics. So for example, we could add an alias for 8th grade math, and that would essentially be a set of the topics in our knowledge tree. Or we could just add an alias which is called 8th grade, and that would be everything from mathematics to humanities to natural sciences that is covered in, for example, the standardized US curriculum in 8th grade. And finally, I think this makes a lot of sense. So in the previous calls and discussions, I was usually mentioning that we'll have sort of a dependency, and then that dependency will have strength. But more and more, I feel like that is not enough. It's much better to have not just strength, but also how much you need to know the other topic, like its depth of understanding. Now, you might say it's very, very cumbersome to enter, essentially 3 fields, because for any resource, you're entering the learning dependency, the topic, then the strength, and then the depth. But I feel like the latter 2 can be reduced to 1. So this is actually part of what was initially in the specification, which I wrote in December. This just built in NASA part 1. So let me just show you that real quick. So for me then, a dependency was to which topic it is. And then I had something which I called required level at 3. And it was between 1 and 7, but now we have a different concept of depth. So now it will be between 1 and infinity. And how would it work? So we're still keeping the dependencies having 5 strengths, which is very, very nice. But we do this required level at 3. So what does that mean? So what level, what depth do you need to know the other topic that is being recommended? So essentially, what are you recommending to the community, to anyone using our app? What level, what depth of understanding are you recommending that they know the other topic in order to learn this one? I hope that makes a little bit of sense. I hope I described it at least a little bit legibly. But let me give you an example. So the rest will be extrapolated on a unit scale. So for example, required level at 3 equals 3 will give the following recommendation set. So it would be, it's absolutely necessary that you understand it at least at a depth of 1. It's strongly recommended you understand it at least at a depth of 2. It's recommended you understand it at least at a depth of 3. It will be good if you understand it at least at a depth of 4. And it will be okay or cool if you knew it at a depth of 5. So I like how this sort of gives us a recommendation set. You absolutely have to understand it at some basic level, but it would be nice if you understood it at a higher level. Similarly, let me give you 2 more examples. Required level at 3 equals 1 would give It's recommended you have some very basic understanding of the topic, but it would be good if you understand a little bit more, and it would be cool if you understand it even a little bit more. And finally, required level at 3 equals 7, which means it is very necessary to understand this very, very well. But it is strongly recommended to understand it super well, and it's good to understand it, like to be an expert in it. Yeah, so it's absolutely necessary to have a very good grasp of the dependent topic. And I guess the main reason why why I'm like putting this into the model is because we also want to encode difficulty, and we don't want to have a separate field for that, but rather difficulty can thereby, using this, be encoded as a dependency. So now you can finally have a circular dependency. So you can say this blockchain article talks about blockchain, and it obviously, hopefully expands your understanding of blockchain, but it's not a blockchain 101 article. So you have to have some knowledge of blockchain before you go into it. And that's essentially how we encode difficulties, because this blockchain article is difficult. It's not an entry-level one. And we do that using circular dependencies. Cool. So that's what I wanted to say about required level at 3. Now, actually, I'm going to jump a little bit here. So while this field has a really, really weird name, required level at 3, I think that we nevertheless should make the whole app, at least the Chrome extension, human readable. So we won't be using numbers. We'll be using adjectives or phrases, right? So instead of saying this has a dependency of required level at 3 equal to 4, we'll find a human way to say that, and the user will be doing a select option, not from 1 to 5, but from a list of human readable phrases, because that makes the onboarding much easier. People don't have to go to the amos.ms/help and read what the levels, how they're actually defined, because the definition is in the UI. And furthermore, yeah, for other metadata, it feels very, very natural to me that we should do that as well. So if we'll have some concept of quality, the set of metadata has not been decided yet. I think that's another thing we need to do. Maybe after the UX or before, whatever, is find the set of metadata. But for example, if we'll have a metadata field called like quality, or quality of explanation, then we might add, like, rather than like 1 to 5, how good this is, like stars or something, we'll say like this is like amazing, excellent, great, good, and okay. Cool. So let me get into the next thing on the list. How do we get content? So that we can split it up into 2 things. How do we get the knowledge tree, and how do we get resources? And how do we get their dependencies? So let's have a look. So for the hierarchies, I think we should start with, it's obviously going to be like, the very first version. We're gonna set the knowledge tree, the topic hierarchies, and then we'll have some functionality of changing that. It's really, really cool that we're using a graph database, because that allows to change these trees in a time span of O of 1. You just change the relationships. while something like a key stored database would probably be O of n. And so I think for the very first version, we should use existing structures or attempts to hierarchize these fields. A very well-known thing is this system called math knowledge management. So let me tell you what that is. Actually, I think I got the wrong keyword. It seems like it's a study, but nevertheless, it's quite interesting because of this sentence. Mathematics is particularly suited to a systematic study of like categorizing or hierarchizing knowledge due to the high degree of interconnectedness between different areas of mathematics. So I really like that. So this again enforces that we're going the right direction. If we're able to create our app for something like CS or math, where there are very strong dependencies, there are very high degrees of interconnectedness between different topics, then it will be much easier to do it for something like history, where the dependencies are weaker and the interconnectedness is, at least at face value, not as large. What was the keyword I was looking for? Math. How do I find it? Mathematical. Maybe I should see if I have it over here. Over here. Oh, I think I got it. Yes, so this is the keyword. Mathematics subject classification. So this is a global standard for classifying math papers. There exist equivalent ones for computer science as well as for physics. But yeah, so that's that. What is good about this is that, I mean, it's a proper project. They did a very good job of categorizing these fields. In fact, I even for some reason decided to put it into code so that we could, yeah, in the future run some script on it and just put it into the database automatically. But yeah, so they divide mathematics into the foundations of math, into algebra, which includes pretty much everything you were doing in high school, into analysis, which you might do if you're doing math or something very technical like engineering, and then geometry and topology, and applied mathematics, which also includes, I would say, like probability theory is like quite a pure subject, but they actually consider it applied, and like it includes like intersections with physics, such as fluid mechanics. So that's what's good about this stuff. Is like they did a pretty good job. Oh, and by the way, like all these have like lots of subcategories. So the entire specification for this classification, the PDF, it's like, you know, like 30 pages. Let's see if I have it. I might have it. No, I don't think I do. Okay, so that's the good stuff about it. Why did I say there's something bad about it? So the bad part is, you know, this is meant for academic papers. We're doing not research, we're doing education. But nevertheless, I think that it can, and also they're domain specific. So this is all of math, and there's all of CS, and there's all, but we're like, our interest is in connecting them, right? So if you have something like history, or you have like something like biology, or like, you know, CS, or like astronomy, then like obviously in our system that wouldn't be part of the math tree, that would be part of the physics tree. Nevertheless, I think it can serve as a very good base, and together with some advisors in these topics, math, possibly physics, NCS, we can make the basic structure for a knowledge tree. And then depending on community discussion, that can always be changed. Yeah. Then, we also talked about in the last call about either having a kind of a soft consensus mechanism, as in like maybe we set up an external forum or like a chat or whatever, and then whichever one seems like the most wanted by the community, we accept. Or we could also have a slightly harder consensus system where we actually do some concept of votes, etc. And whoever gets, whichever proposal gets the most votes, we go with. Or we could do a combination of both. You could describe and discuss the proposals on discourse, but then we just add a simple plus and minus button in the app. But that is all coming in community rules. So that's that. Dependencies. How do we do that? So turns out there actually do exist like existing dependency graphs. An example would be the developer roadmap repo on GitHub. I am not going to Google it now, but a few weeks ago I found similar images for mathematics. And one option is to sort of do this even on a technical layer, where we make a concept of a natural dependency, and we enter everything we find there from the developer roadmap, from the math tree, and that wouldn't really have any technical value, but it would have UX value. So if somebody, like let's say there's a natural dependency between cryptography and number theory, so then when somebody enters a cryptography resource, we suggest that maybe it depends on number theory, because we have this like pre-filled in set of natural dependencies. So that is another idea. So that we can sort of like make it slightly more better and structured to get the dependencies. How will we get the resources? So I propose we start with 5 sources. The way I personally learn math, whatever math I want to learn, I go to this URL right here, and that actually is really, really good. So this lists every single course that is going on this year in at Oxford Maths Institute, and as far as I remember, almost every single course has the lecture notes and the problems. So for example, let's say you wanted to learn about Introduction to University Mathematics, click, and bam. You have the problems and you have the full, let's say 80 pages in LaTeX. Whenever I want to learn computer science, I go to this link right here, and this is from Cambridge. Same thing. Whatever you want to learn, you let's say you're interested in learning about, let's say you're interested in learning about algorithms. You click on it, and you click course materials, and bam. You have everything you need. And I think we should also do the 100, like let's say 100, maybe it could be less, like 50. Just like, and there's very likely chance we won't be able to find like some list of like, assorted most popular courses on these platforms. But there's ways to get around it. Like Udemy, they have 20 categories. We click on each category, and I think you can sort by like most popular for each category. Just whatever, like 50 to 100 courses, like in some degree, they represent like some of the most popular courses on the 3 most popular learning platforms. And I think if we do all of that, then it's a pretty good start. So you can learn pretty much all of undergraduate maths. You can learn pretty much all of undergraduate computer science. And these are very likely to be a combination of software engineering, like computer science also, business, whatever people are learning on these platforms. I guess now that I think about it, we should be taking a subset of math or computer science because that's what we're going with at first. And yeah, we are not making topic hierarchies right now for non-tech subjects. But yeah, I mean, just these few sources would be, probably around 8 years of education. So, and so how do we do all that? So very simply, we write a script that gets the prerequisites. So for edX, they have, they have a field called prerequisite knowledge. For Udemy, there's a field called prerequisite knowledge. And for Coursera, there's a field called prerequisite knowledge. For these two, it's a little bit more tricky. So for Cambridge, they sometimes they list it, but I'm getting the feeling that they list it only for like postgraduate courses. So actually no. So for example, algorithms does have a field called prerequisite courses. So that's actually quite optimistic because algorithms is a first year course. With the Maths Institute though, like if we have a look there, so this Gödel's incompleteness theorem, it's there. Like yes, the requisites are there. So I think it's because it's an optional course. For optional courses, they're there. But if we go to something like, remember I had the introduction to maths. Where was that? Or like let's say we go to something from first year, like analysis 3s. Let's see if that has, yeah, so see, that does not have prerequisites. Two things I want to say. So I'm not, a professional mathematician or a professional computer scientist. So for those that don't have prerequisites, we can contact our academic friends and they can help us fill those prerequisites out. And most importantly, once we have the prerequisites, well, in some text format, because the script will it will be a scraper and it will get all the prerequisites in text format. Then we can very easily manually parse it and structure it. So if there's a prerequisite of learning, for example, I was looking at the compiler course on Cambridge. There was a prerequisite to know discrete math. So bam, you have now you can do the first. We have to have the topic hierarchies, and then we can link to that with the prerequisites and have it be structured. And so one challenge that will come up is usually for the maths and for the Oxford and the Cambridge stuff I showed you guys, the prerequisites are usually with respect to their own courses. So that's going to be a bit of a challenge, but for example, if we know already which topics the courses are on, then then that's all we need. So then we do it that way. We could also do this on the technical layer where we say there's like one like recommended dependency, which is an actual resource. But then there's like in our model, right, like resources have dependencies, but the dependencies point to topics. So there could be like one like recommended dependency, which is internal for the organization. But then we could also do the more abstract one, which points not to a resource, but to topics. So yeah, I think all of this, let's say 1 or 2 people working on it, I think all of this could be done in 2 weeks, and we'll be able to hydrate the database really, really well. And I mean, yeah, I really think we'll have a lot of content. We'll have content to the level where like you could almost be using it in the search functionality, even though that is won't be available yet. So if we roll this out with like just this doing doing all this internally, then I think the world will understand that we mean this seriously, and will help us to fill out, let's say, 50,000 more learning resources. And then we can introduce search functionality, and we can help any student in the world learn anything they want with a recommendation engine that is better than any single human on Earth. Finally, let's talk about, so the app, initially there was this idea of like mod.amos.ms. I didn't think about it for that long, but it seems like amos.ms suffices. You go there, there's some text saying search is under construction. For now, you are welcome to help us categorize human knowledge. You can sign up with Google or Facebook or email, and you can get into the app. So what I'm trying to say is I think it makes sense that it's all in one app, even in the future. You can get into the app, amos.ms, and you can start submitting. You can obviously view what our work so far. You can vote on issues. Everything. And we'll also have a Chrome extension that I already mentioned this point. It's cool if the users don't have to go back and forth between the definitions of our levels, but the definitions are straight in the app. Another cool thing that is off topic, but it's cool, is there's actually standard for browser search. So if I type W, it will search Wikipedia. If I type G, it will search Google, I'm feeling lucky. If I type A, it will search Amazon. It will be very easy to make Amos adopt that standard in the future. Once search is introduced, you'll install the Chrome extension, you will enter A space, and you can search the Amos platform. It's literally 2 characters away from being used. So what are the next steps? I personally will be thinking about these 2 things the most in the next few days, as well as this. So what I want to work on tomorrow and think about today and start working on tomorrow is the actual community rules. How does everything work? Anonymous stuff. Maybe I might ping Anya for some advice. Like if you allow anonymous submissions, what if somebody starts spamming, right? So then we have to block their IP. Is it possible to locate the computer that it was done from? Because unless I'm mistaken, universities or companies, if they're on the same network, have the same IP address. So then there's some concept of like some gateway mask or subnet that allows you to distinguish. And I think you can even find this in the browser with JavaScript code. And if that's the case, then whether that's the best way forward. And also be thinking about everything like reputation and stuff. I found a very good book on building online communities. It was released about 6 months ago. by a world-leading expert called Richard Millington from London, United Kingdom. And it's very, very well rated. I might purchase that and read it this evening. I read one of the reviews. The reviewer was saying the main thing to take away from the book is to what person is your community indispensable, right? So you want to create a community of people, of contributors, and of users, such that your product creates a lot of value for them. So that's going to be really interesting to think about that, because yeah, definitely part of our initiative, part of our project is building a community. And also, I'll be thinking about the UX of the app and of the Chrome extension. If Ash is available, then I will be getting in touch to talk about this, and maybe even come up with some cool mock-ups for this app, for this project. And finally, yeah, I think this is really finally, so let's put it at the end. So also, so I wrote into their Discord that we have a talk on Friday at 3 p.m. So let's find out if they're available and if we are all available, and if so, then we can talk. I feel like, you know, we definitely have a plan of what to do if the cooperation doesn't work out. But if we finally, you know, come up with a specification, with a community specification from like a game theoretical perspective, and possibly some mock-ups, then I think we'll be in a much more specific position to talk with Nikita from Learn Anything to see if he wants to join forces. Yeah, because there's no point talking when like we don't know yet what we're building ourselves. But once we actually have an idea of what we would do if the partnership didn't work out, then we can talk and see if we can make it work. And if we not, we get back to our roadmap. And finally, at some point, I'll be looking into the set of metadata that we actually want for our app. So yeah, like long story short, to conclude everything, we got a call on Sunday where I was expecting that the next 2 weeks will be focused on the specification. And I'm really, really happy that I feel like what we have right now is workable. Like, we can actually make it work. And now the main challenge is to define how the you know, our micro economy or micro society will work together, and then we can start designing and start building and start also categorizing. So yeah, that's it. Thanks a lot, and let's have a public discussion, and then let's stop recording. And if you guys want to mention anything privately, that is also fine. Any comments regarding the specification, the categorizing, the hydrating of the database, or of the any ideas about the community? Okay, cool. In that case, thanks a lot for watching this video, and I hope you join the community.